All right, guys, so today we start 5.5 in trigonometry and 4.5 if you're in pre-cal. So for the next two sections, we're going to be learning how to graph trig functions. Okay, I'm going to try and split this up in the videos. The first video will just be the explanation of what the 6 trig functions look like and how to draw them. And then we're also going to see how they move. So whether there's transformations, if they move up or down, left or right, or stretch or shrink. And then I'll start off the following video with just doing examples. Okay? So to start off what the 6 look like, let's start off with sine. Okay? Sine starts at 0, goes over, and then under. Okay? I'll always tell you some silly little way to remember. And I tell my classes that sine looks like if you chopped up a stop sign. So you can kind of draw the letters of a stop sign. Again, whatever it takes to help you memorize it. Okay? Now, notice that the graph goes up to 1 and down to -1. Okay? On a parent function, they only stretch up and down to 1 and -1. This will be for all 6. Once we start stretching and shrinking, you're going to see, like just in the past in algebra, how there was a number in the front of the function being multiplied. Like if I said 5 sine of x, this would go up to +5 and then down to -5. Okay? So the letter that you'll see in the function is a letter A. The letter A stands for amplitude. Okay? So you could put a little +A and -A, because when you see the equation, that number that appears in the spot of A is the number you will put in those two spots. And that will be true for all 6 trig functions. Okay? Now, sine goes over and it hits a maximum at its first point. It comes back to the midline. Right now, the midline is just the x-axis. It goes down to its minimum at its 4th point, and then back to the midline at its 5th point. So these 5 points are very important. Every time you graph one of these 6 trig functions, there are going to be 5 points, okay? If you can't match up the 5 points, that's a red flag that you're making a little mistake. So for a sine graph, the 5 points go midline, max, midline, minimum, back to midline, okay? If we ever have a scenario where the graph starts moving up or down vertically, then our midline changes, but that scenario of over then under still stays the same, okay? What do you guys think is going to happen if I ask for a negative sine graph? Exactly. It flips, and instead of being over then under, it would just go under then over. Okay? Now, keep in mind that all of trig functions go on forever. They're like a wavelength. Okay? So think of like a heart monitor or like a sound wave, a wavelength. What we're graphing in this chapter is just one cycle of those wavelengths. Okay? So in your textbooks for homework, if they say to graph 2 or 3 cycles, no need. I'm a firm believer, if you know how to graph one, you know how to graph all cycles. You just keep going and going, okay? All right, so that is our sine function. Let's move on to cosine, okay? So cosine, the big difference here, again, we still have our 5 points. Starts at the top. It starts at its maximum, is its first point. Then it goes down to the midline. 3rd point even lower to the minimum, 4th point back to the midline, and 5th point up to its maximum. Okay, and if you want a silly way to remember this, if instead of cosine of x, it was, whoops, I can't spell apparently. If instead of cosine of x, it was cosine of y, what does cosine of y say? Sort of. Cozy. It looks like a hammock. So draw your guy chilling here. Or girl. It's got a really long torso. Okay? It looks like a hammock. Okay? Or a valley. So what do you think a negative cosine function would look like? A mountain. It flips. Instead of starting at its maximum, it would start down here at its minimum, come to the midline, go up to the max, back to the midline, and down to the minimum. Okay? Now, there's something I want you to analyze in both the sine and cosine function with your unit circle, okay? So in both of them, let me see if I can zoom out really quick. In both of them, notice that the points go from 0 to pi over 2 to pi to 3 pi over 2 and then to 2 pi. Those should seem really familiar with your unit circle, okay? If I'm talking about one cycle of a trig function, I'm talking about one cycle on the unit circle, okay? So a full unit circle is 2 pi. Cut that in half, I get pi. Cut it in half again, I get half a pi. And then, of course, 3/4 of it is 3 pi over 2, okay? So watch how the points end up matching with a unit circle. What is sine of 0? We're looking here at sine. Sine of 0 is 0 on your unit circle. You see I'm still at the origin? Sine of pi over 2 on your unit circle is 1. Sine of pi on your unit circle is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So the points on these graphs match with those 4 main points on the unit circle. Okay? Same thing for cosine. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is also back to 1. So if you ever get stuck with these, maybe you can relate back to the unit circle. How are we doing with these two? Good? All right, let's move on to tangent. So where sine and cosine look more like wavelengths, tangent looks more like a heart monitor. Okay? So this image did get a little faded. This does keep going down. And it does keep going up. Okay? Now, I know it's hard to see the 5 points here. They didn't come out on the image. I'm going to draw the other ones. Okay? Very important to know about tangent and his reciprocal, which is cotangent. Instead of having a cycle of 2 pi, tangent and cotangent have a cycle of a single pi. Okay? So, a single pi, if I start in the middle, half of a single pi would be 2 pi to the right. Pi over 2 to the right and pi over 2 to the left. Does that make sense why those numbers are there? So if I'd go halfway to pi over 2, what do I end up at? Good, guys. You're right. The answer is pi over 4. All right. And then halfway to negative pi over 2 would be negative pi over 4. Again, these are for a parent function, okay? Now, hopefully it's obvious to see that the middle point is at 0. These 2 points match up with that amplitude. So again, if it was 5 tangent of x, this would be a 5, and that's what this point matches up with. And this would be a -5, and that's what this point matches up with. Now, the 2 outside points are not technically part of the tangent function. They are the asymptotes, okay? Remember how in your unit circle there's times where tangent gives you undefined because you were doing like 1 over 0? That's the location of the asymptotes, okay? So think of sine and cosine more like a wavelength, and think of the tangent functions more like a heart monitor where it goes beep, beep, and then takes a pause. Beep, beep, takes a pause, okay? So another very important thing to know about tangent. Notice that sine and cosine started at the origin and then went on towards the right in the positive direction. Tangent, make this as a side note, is the only trig function that is centered at the origin. So I'll write that here. Only trig function centered at the origin. All right, so moving on, we're going on to cosecant, okay? So cosecant and secant are reciprocals of sine and cosine, okay? In my class, I like to use the nickname flip-flop. Reciprocals like saying flip-flop. So notice that if cosecant, let me zoom out a little bit, is the flip-flop of sine, I have here drawn dotted a sine graph. Now that dotted is not part of my cosecant graph. It's just going to be what helps me draw my cosecant, okay? So anytime you're going to do cosecant, and this is going to work the same for secant in a moment, anytime I hit the midline, I'm going to draw an asymptote. So I'm going to draw an asymptote at the midline. And then I'm going to flip parabolas. So again, play on words with a flip-flop. So notice sine, I drew the over then under with the 5 points on the sine. My 5 points go 1, 2, 3, 4, 5. Okay, I drew an asymptote on the first time, the second time, and the third time that I hit the midline. And then here I have one parabola. What used to be my maximum on the sine is now a minimum on this parabola that flips up. Okay, and again, remember asymptotes, we ride along them, we don't cross them. And then on this portion that looks like a parabola, what used to be my min is now a maximum on this parabola. Cool? These should, cosecant and secant should feel like the easiest to draw. Once you know sine and cosine, for example, if I gave you an equation that said 5 cosecant of 3x minus pi, you're going to do that whole problem like if it was a sine, and then at the very end, you just flip-flop. Okay? All right, so let's move on to secant. Once you learned that system, how sine works with cosecant, the same exact thing here happens with secant. So I'm going to draw secant dotted as if it were a cosine graph. Cosine only hits the midline twice, where sine hit it 3 times. So that's why this one only has 2 asymptotes. So I draw the asymptotes at the midline. Now down here on my third point, it was a minimum. And now because I flip the parabolas, it becomes a maximum. And now up here, these are maybe a little harder visually to see. This is like saying half of a parabola, right? Like if it would have kept going this way. So I flip that one up and I just need to draw this half of the parabola. Same thing over here. It's like if it would have been a full parabola. Okay, but I only need to draw half. Okay. So you have 1, 2, 3, 4, and 5 points. And lastly, we're going to move on to cotangent. Now, cotangent is very similar to tangent, which in my opinion, it's what makes it the most confusing one, okay? So again, it came out a little faded. I apologize. So keep in mind that tangent was the only one centered at the origin. So cotangent looks identical to tangent, except for 2 things, okay? One is that, like all the others, it starts at the origin, okay? Remember, we do have these 2 extra points here that match up with the amplitude, okay? And the second thing that makes it different is that tangent starts from under to over, and cotangent does the opposite. It's like a negative tangent almost. It goes from top to bottom, okay? A little shortcut to help you remember, I always think that tangent looks like the x cubed graph. Remember when we do the robot? Tangent. So the difference between x cubed and tangent is that tangent goes only up until the asymptotes, where x cubed doesn't have those asymptotes and it goes forever. And then cotangent would look like a negative x cubed. It goes downward. Okay? So a quick recap. All 6 trig functions except for tangent start at the origin. Sine goes over then under, while cosecant is the same thing but just drawing the asymptotes at the midline and then flipping the parabolas. Cosine starts at the top and draws more like a U, like a valley. Secant is the same as drawing cosine, but adding the asymptotes at the midline and flipping the parabolas. Tangent and cotangent, on their 5 points, the outsides are asymptotes, and the 3 in the middle have to do with the graph. Tangent, again, being the only one centered at the origin, it looks like an x cubed graph, and cotangent looks like a negative x cubed graph. And those are your 6 trig functions. All right, for the last part of this video, it's how we start moving these graphs, okay? So the equation will be given to you in this format, okay? The plus or minus will determine whether you flip it or not, okay? The A, like on the sine graph I showed you, is the amplitude. So if it says 5 times sine, then you just go up to positive 5 and down to negative 5. Where the word trig is, it will be replaced with one of the 6 words, sine, cosine, tangent, and so on. B and C are going to affect, remember when it's inside the parentheses, which way does it move? Side to side, opposite the sign. So in this case, B and C are going to move side to side, opposite the sign. You've seen this before. The only one that might feel new is B, okay? But you've done this with algebraic functions, moving it side to side, opposite the sign. And outside the parentheses, how does it move? Up and down, same as the sign. So that stays the same from how you learned in algebraic functions, okay? All right, so now this chart is the one that I hope you'd be able to build on your own every time you do a problem. All right, so the first thing you need to identify in your chart is which of the 6 trig functions am I working with. Once you know which of the 6 trig functions you're working with, you pick it off of the other side of this worksheet and you keep it on as a side note so that when you're done finding all the details, you know whether to go over and under or like the hammock, okay? The next thing you're going to pick is whether the function is going to be positive or negative, okay? Next is your amplitude. This is the number being multiplied in front of the trig function, okay? This is the height and the depth. This is how much you move upward from the midline and down from the midline. So add that there. It's a height and depth from the midline. Okay. Next is the cycle. Sometimes in your book it says cycle, sometimes it says period. That just means the length of one full of those like overs and unders for the trig functions, okay? Now, tangent and cotangent like to play by their own rules sometimes, and you're going to see that I put 2 sets of rules. So, analyze that for all except for tangent, cotangent, the way you find the cycle is you write 2 pi divided by b. A reminder that b is found as a number multiplied in front of that x. Okay? So again, this will be true for sine, cosine, cosecant, and secant. And then pi over b works for tangent. Okay? The way I like to remember it is instead of all 6 rules, I remember 2 of them. I remember sine and cosine and their flip-flops. And then I remember tangent and his flip-flop. Okay? Now I apologize for my handwriting. I made a mistake here. Horizontal shift, moving side to side, has to do with inside the parentheses, just like in our algebraic functions. So to find out how much I'm moving side to side, I need to do the C divided by the B and then move opposite the sign. Make a star here. This is usually where people get stumped because they forget to flip-flop that sign. Okay? So if it said 5x minus pi, I'd be writing positive pi over 5 as my horizontal shift. Okay? This is also going to be my starting point. So remember I told you all of them except tangent start at the origin? Well, if I have a horizontal shift, I'm no longer at the origin, I'm at that point. Okay? Which, if you look at the first thing on 5 points, it says I'm either starting at the origin or at my horizontal shift. So, this is also my starting point. Vertical shift is one of the easiest to see. Okay, it is just D, same sign. So if it said plus 5 at the end, it means I move up 5. The easiest way to do this is to count D as your midline. Okay? I even like to draw a new dotted line wherever my midline is so that I know that is where I'm going over and under from. So one more time, if I move up 5, now 5 is my midline and I go over at 5 and then underneath at 5. Okay? All right, increments. Increments is something that's going to be needed for the 5 points. Okay? I'm going to flip over to the sine graph really quick to explain to you increments. I put 1/4 times the cycle. Okay? So, to give you a visual, we had said that 1 full cycle of sine is 2 pi. Okay? If I want to create 5 points, in order to create those 5 points, I have 1, 2, 3, 4 portions of this graph. Do we see the 4 portions in order to get the 5 points? Okay, so if I want to know what my increment is, how much to move to the next point, I need to divide that full cycle by 4 or multiply it by 1/4 so I can find out how much to move over each time on the 5 points. Does that make sense? So for that reason, once I have found what my cycle is for that question, I just multiply by 1/4 and it'll give me how much to add every single time for my 5 points. Okay? So that side note is written right here. Let's take a look at our 5 points. Okay? I either start at the origin or the horizontal shifts, and then I'm going to add the increment to get all of the next points. Okay? The only one that has something different is tangent. If we are talking about a tangent graph, instead of starting at point 1, remember how it starts at the middle? We put our 0 or horizontal shift at point 3, and then we add to get to point 4 and 5, and what do you think we do to get to point 2 and 1? We subtract. Okay? So if you can build this chart, I know it seems a little overwhelming right now. This is going to make so much more sense when we see an example. Once you have all that information down, you're going to want to draw things in this order. You're going to first want to place your midline and your amplitude. So draw that new dotted line, and let's say we went up 5 and we drew our midline there, and let's say our amplitude was 2. Now I'd go up 2 from 5, which lands me at 7. And then down 2 from 5, which lands me at 3. Okay? And that's where I draw my over and under. Step 2 would be to draw the 5 points, so I know how wide or narrow to draw this. And then lastly, I either draw the trig function in the positive or negative direction. So again, all of this will start to make so much more sense when we see it in an example.